Welcome to Biomedical Engineers TV. In this video, we will look into surgical lights or operation theater lights. So let's start the video by looking into the history of operation theater lights in the 1900s. Before electricity allowed light bulbs to illuminate an operating room, candles were used as a light source during a procedure. Additionally, surgeries were performed during daylight hours so surgeons could use the natural sunlight for illumination. Surgical lights, as they are recognized today, have evolved over more than a century since electricity was first discovered in 1879, with surgical light manufacturers continuously working to improve lighting conditions for surgeons and OR staff. In 1959, the first lamp to use halogen gas, chlorine, was patented in 1882, but the first commercial halogen lamp that used iodine as a halogen gas was patented in 1959 by General Electric. With the introduction of light-emitting diodes, or LED, as light sources, the problem of heat radiation was removed, while energy requirement was reduced. In an effort to reduce the heating, optical condensers were used in an indirect light, but they were not a success. When the electrical lights made their entrance into the operating room in the 1880s, it also quickly showed problems. At this early stage of electricity, the ability to control the light emitted was very low, and the light created was still moving and diffused with great heat radiation. What is shadowless operation theater lights? Surgical shadowless lights have been developed to the present and have undergone various technological innovations, and their performance has continued to evolve. As an important medical device in the operating theater, it solves the problem of the sight interference caused by the shadow to the doctor, greatly improving the safety of the operation during the surgery. The surgical shadowless lamp is designed based on the principle of multi-point light source effect. That is, when there are multiple light sources illuminating an object, some of the light from the light source is blocked by the object and cannot reach the receiving surface, resulting in shadows. While the light from other light sources illuminates this shadow area from another angle, thereby weakening and eliminating the shadow of this area, and finally forming a shadowless area. In simple terms, shadowless light consists of multiple light sources with different angles, and the area where light source A will produce shadows can be illuminated by light source B, which makes the surgical light shadowless. Make sure that every place has at least one light that can be illuminated to eliminate the effects of shadows. Let's look into components of LED-based operation theater lights. There are 5 major components at the outside of the OT lights, which are the closer knob, handle with sterile touch control, or STC, MedView HD camera, adjustable color temperature and light field diameter, and the control panel with touch technology. Inside the light, the major components are power supply, LED driver assembly, and LEDs. So what are the types of surgical lights? There are various types of surgical lights, and each type plays specific roles in illumination before, during, and after a medical procedure. They can be categorized by lamp type or mounting configuration. 2 lamp types are conventional or incandescent, and LED, the light-emitting diode. Surgical lighting configurations may include ceiling-mounted, wall-mounted, or on-floor stand. Depending on the model, a surgical light may also be used in all 3 configurations. 1. A ceiling-mounted light can be mounted on a fixed point on the ceiling of a procedure room. Similarly, wall-mounted lights are mounted on the wall of the OR. The wall-mounted configuration is more often used with examination lights versus surgical lights. For greater mobility, floor-standing surgical lights are standalone and typically on wheels, enabling them to move room to room. Mobile floor lights are often used in examinations. All 3 types play an important role in illuminating a surgical site during a procedure. Let's look into the technical considerations of OT light. The first technical consideration, the lux. The unit of measurement for the amount of light at a given point is measured using a lux meter at that point. 1 lux is equal to 1 lumen per square meter. The second technical consideration is color rendition index, the effect the light source has on the appearance of colored objects, tissue for example. This is a measure of the quality of light. Natural daylight has a CRI value of 100. The closer an operating theater light CRI value is to 100, the better its ability to render true colors to the human eye. It is important to appreciate how well the light renders a saturated deep red color, which will allow the surgeon to recognize details better in the area of the wound and to distinguish between tissue colors and arterial or venous blood. The third technical consideration is color temperature. The perceived coolness or warmth of light is measured in Kelvin. Some LEDs permit the ability to adjust color temperature, which allows a surgical team to manipulate the light characteristics and hence facilitate tissue differentiation. The fourth technical consideration is color temperature central illuminance. The illuminance, or 1x at 1 meter distance from the light-emitting surface in the light field center, and is measured in lumens per square meter. For good performance, it is important that the light is capable of achieving both a high illuminance and good color rendition simultaneously. The fifth technical consideration is color temperature light field center. The point in the light field, the lighted area, where illuminance reaches maximum lux. It is the reference point for most measurements. The sixth technical consideration is color temperature depth of illumination. The distance under the light-emitting area where the illumination reaches 20% of the central illuminance. The seventh technical consideration is color temperature shadow dilution. Refers to the light's ability to minimize the effect of obstructions. An absence of cast shadow or colored shadow is described as perfect shadow dilution. The eighth technical consideration is color temperature light field diameter. Diameter of the light field around the light field center, ending where the illuminance reaches 10% of central illuminance. The last one is fail-safe, the backup possibility in case of interruption of the main power supply. This was the simplified video on Operation Theater Lights. I hope you liked this video. If you did, please give us a thumbs up and subscribe down below. Thanks for watching, and I'll see you guys in the next video.